Alright, so here we are. So as I was saying, the goal for today is to do review. We're going to go over some of the concepts that we went over at the beginning of the class up until where we started developing for VR. Um, Later down the line, we'll likely do another review session about the VR concepts. For now, let's do a deep dive into what we've done before, and we'll do a little more. We'll even do a little bit more detailed explanation of certain things that we've done before. So, I don't think we need to review who I am. You should damn well better know that by now. The interface. Let's go over the interface. So real quick, the scene tab is your view, your window into the world. It is only the editor itself can see through this line. Allows you to sort of keep track of everything that you've put into your scene. Alright, and then with that said, the hierarchy tab here on the far left is what lists off every object in your scene. And the one on the right here, the game tab, likely you probably started off with it being one big tab here. One moment. There we go. Oh. Sorry, just a moment. There we go. So you likely had to toggle between the two. The game tab is what the user of your application sees. The asset store tab is a great resource for finding whatever asset you want. Just type in something that you like you can say sounds, explosions, and it will find you a series of assets that are explosion sounds, and you can always filter by price. Like I want stuff that's cost $0, so that'll be everything that's free. Now on the right side here, so let's say I select something in my hierarchy tab. It's player. Select the player. Go back to the scene view. Then on the far right side in the inspector, it's going to list off every property and component of that object, starting with transform. This is an important component. This is what determines the position, rotation, and scale of any object that you select. Every single object in your scene will have one of these, with the exception of UI elements like text. Let's see if I have anything here. Where's the canvas? Here's my canvas. So unlike a typical transform, UI elements have what's called a rect transform. So same type of object, same type of component, but a little different. That's it. The positioning is based on anchoring and all this resolution stuff, so a bit more to it. Now going forward with that, we're going to look at one of our objects here. So let's select this cube here. Let's take this cube. You'll see this cube. It's a primitive shape. Primitives are just the word just refers to the basic cubes, cylinders, spheres that come with Unity. You can see its transform provides its position, which happens to be 165, 30, and 745, XYZ. Now if you want, you can manipulate this object's position by selecting the Move tool, top left in the toolbar, Rotation tool. You can also manipulate its scale, and a couple that we might not have gone over is the Rect tool. This will allow you to sort of resize it as if it was a window, like you would have in your File Explorer or your Finder. Resize it like a window, or along just one axis at a time. So one of the upsides to that is if you are using the typical scale and you want to just scale it, make it bigger on the right, it makes it bigger on both directions. With the Rect tool, you can just go off to the side. And this will allow you to do two axes at will. And finally, the last one here is the, let me just make sure and yeah, you can also move it by selecting the little circle in the middle, in the center of the object. The last one just allows you to see all the first three at once. So move, scale, and rotate all at once. So you see all three. Now one of the things you may notice is the arrows pointing out from the center of the object. Blue arrow represents its Z direction. That is its forward direction. Red is going to be its right direction, which is X, and up is Y, which is green. So one of the things may not have come across is the fact that if I rotate this object, you'll notice that, yeah, blue arrow is pointing in the direction that's the object considers to be forward. But if I accidentally have my little toggle here at the top left set to global, this will maintain pointing in the world's global direction. So even though the object is facing up technically, it's still pointing along the world's Z axis. I switch to local, now you'll see that it's looking up. Alright. Now, a quick little extra is if you want to change the size of your gizmos, like see that camera icon, you can change the size with the slider here that you can get to with selecting this little gizmo button at the top right of the scene tab. If you're ever searching for any object here, you can just type in the search bar and it will basically blur everything else out except the object that you're looking for. The object which has that word in its name. Alright. Now in terms of the object themselves, so a brief review of the movements of the manipulations of the object. Now manipulating your view of the world. If you hold down the right mouse button, you can look around. If you hold down the middle mouse button, you can pan around. If you use the arrow keys on your keyboard, you can move along the XZ plane. The longer you hold it, the faster it moves. You hold shift, it goes even faster. Now if you hold the alt key, you can use the left mouse button, click and drag, and that will let you keep your focus on a particular point and look around that point. If you're holding down the alt key and you hold down the right mouse button and click and drag that, it will zoom in and out. And if you hold down the shift key while you're doing this, it will dramatically speed up how fast you're doing that as well. A few shortcuts for those tools, by the way, is QWERTY. Speed up your development process, you can just toggle between them. Okay. And quick review of parenting. You notice a lot of these objects have these little toggles at the left side of them. Those are to let you know that these are parents, and then if you click on the drop down, it will list all of its children. The main thing with the parents is that the child will mimic the parent's transform. It will keep the relative position of that parent. Nothing else really is affected. The only extra thing you get is the ability to find an object through its child or parent. So that's really the one extra thing. Just knowing that part, let's see what else we should do. In terms of, yeah, so we'll go over creating a train again here in a sec. We'll just go over some of the nuances that we glossed over last time. The cube, apart from the transform component, has some other properties like the mesh filter. The mesh filter is going to determine what this object looks like. The mesh renderer is actually going to show what the object is. So those are the two differences. You need a mesh filter to have a mesh renderer, and vice versa. So with the mesh filter, you can replace what the object looks like by replacing this mesh slot that you see in the component there. So you can replace that by some 3D model. If you decide to put a dragon in there, this will start to look like a dragon. However, it will still be the default white color. If you want to change that, you would click and drag the material into here, and that would immediately replace this list of materials here. And with that said, the box collider is its physical bound. It has nothing to do with the mesh. They are totally independent. When you first add a box collider, it tries to shape itself to the actual mesh, it does the best it can to take to encapsulate that mesh, trying to avoid letting out parts. However, if a mesh is not a perfect box, a lot of empty space will be covered. So you can feel free to manipulate the box collider to fit better to what you want. If you want to click on the edit collider button, you can actually click and drag the box collider and resize it however you want. But if it did a poor job of matching your mesh, you would basically have all this empty space that you're telling the world is occupied. Now, however, you can make the box collider a trigger, that will allow you to find events that occur when you collide with an object. So you can say that, oh, something's entered the trigger zone, and that means something's going to happen. Either by, you can also do this for when an object is staying inside of a trigger zone, as well as when an object leaves the trigger zone. So on trigger enter, on trigger stay, on trigger exit. Those are the 3 functions we use typically when developing sort of events for collisions to occur. Now, let me remove that. We can also look at the rigid body. So here we go. Here's my player. The player has a capsule collider. It's not a trigger, so when I add a rigid body to it, since this one doesn't seem to have one moment, let me find another one. Okay, let's take a look at this guy. You okay, Chad?
Yep.
Oh. Alright. Now, if you see this gun here, it has more than just one shape. It has 2 cubes to make up what it is, and it has some other properties. One of the first things we'll go over here is the rigid body. So rigid body in conjunction with a collider, makes the basis for all physics in Unity. The rigid body is going to allow this object to react to forces as well as properly apply them. Some of the properties include, mass, drag, angular drag. Mass, self-explanatory, is going to help determine the weight of the object. The drag is going to refer to its inertia. The object being heavier may help determine inertia, but drag will actually add resistance to the object. It'll be like adding friction to the object. And if you actually make this high enough, it can actually resist gravity. So if I was to put this, let's say to this cube, it has rigid body, so when I hit play, it will drop to the ground. Let me hit play. Let's bring this to the side here. We'll obviously see this object drop to the ground.
Can I ask you a question?
Yes, Chad, please do.
So, when I do that, I added an object, and it falls through the terrain, it falls through the floor every time I add gravity to it.
So when you add an object and you add gravity to it, it's either the terrain does not have a collider or the object does not.
Okay.
And just make sure that the colliders aren't triggers. If they are a trigger, they will pass through the floor. Just like that.
Gotcha. Okay.
Now, cool thing about these properties of rigid body is the fact that you can, say for example, let's increase the drag to, let's say, about 3.46. You'll see it's now drastically slower. That's because it's resisting gravity and reaching terminal velocity. So let's say I add this up, let's make this like even bigger, let's say it's 5. And so if we make this large enough, we should see it really resist movement. So now if I make this something like, I don't know, 1,000, it's not going to move at all. It's just there's too much friction, there's too much too much drag that the force of gravity cannot push it past it. Now, with that said, there's also angular drag, and that's independent of its movement. Angular drag is going to refer to how quickly it rotates, or how much resistance there is to rotation. So if I do this, I banged it against something, and now it just keeps spinning. Although the drag is going to prevent it from moving, the angular drag will not prevent it from spinning. So let's bring the angular drag up as well. Now when I smack it against something, see that event, it starts to slow down the rotation. Decrease that a bit. So eventually slows down and comes to a stop when it turns terms of rotating. Now the last thing we'll just mention here real quick is the kinematic property. The biggest thing this does, it prevents this object from receiving forces. So other objects will not be able to apply forces to it. However, it will still be able to apply forces to other objects, and you can still set this object to have a certain velocity, an angular velocity. You can still able to make it do pretty much everything else a rigid body can do, except add forces to it. Oh, and then when it is kinematic, it is a waste of processing power to use gravity on. Gravity cannot apply a force to a kinematic rigid body, so there's no point in having that on. And then one more thing is constraints. If you want an object to not be able to rotate or not be able to move in a particular axis, you can start checkboxing these positions. So if I, for example, I can see that the Z direction is the blue line here. If I only wanted to move in that axis, I can say freeze the X and Y positions. That means when an object bumps into this, it will only be able to move this direction no matter how hard you bump it from the other side. If something comes and hits it in this axis, it will not respond unless the force has a minor direction that it can add a little bit of force in some other direction besides simply adding a force from this side. And the same can be said for freeze rotation.
So I can't get the gravity thing that you're talking about to stop working. Can I show you something?
Yes, please.
All right, great. I'm losing my 10%. Okay, can you see?
Yep.
All right, so I push play and my guy will fall through. So
okay,
I went through and I've got this character here, and he's got rigid body, he's got a box collider, and he's using gravity. The plane here, I went and I have a box collider, and it still falls through.
Okay, let's quickly take a look at that the 3D model that you have in your scene.
Okay.
Can you click on Edit Collider in the box collider component? Now let's see where that collider is exactly.
So it's way far away from him.
Mm-hmm. Now that's a quick thing you have to fix first. Can you click on layer 1 and layer 2 and see what those are?
Yeah, it's split. For some reason, when I imported the guy, he has like 2 layers. I don't know why.
No.
Like one of his legs is 1 layer.
Okay. So apart from the fact that those are separated, the only thing is it's very far from the actual center of the ritual. So let's click and drag layer 1 and 2 out of the ritual child. So or out of the ritual parent. So let's select both of those. Yeah, perfect. And continue. Let's double click on one of those. Let's focus in on it. Okay. So now let's create a empty. Right click on layer 2 and create an empty. Perfect. Now let's make this so it's not a child of layer 2. So now let's click and drag this out. Alright, and let's select layer 2 and layer 1. Okay. And let's click and drag them, make them a child of game object. Perfect. So now you at least have a good reference point to go from instead of them being children of an object that are so far away. So that's number 1. Number 2, game object, we can add a rigid body and a box collider to that now. Awesome. So that looks alright. Where's the box collider? Let's take a look at that. Let's edit the collider. What? Why is it so far away? Okay. I think it's just a matter of mismatching where these things are. Can you unchild layer 2 and layer 1 again? And select on game object. Okay, let's move it so that it's closer to the ritual object there. And then use those arrows there. Bring it up and over. Let's change its rotation to 0, 0, 0. Yeah, the pivot for this 3D model is really weird, so it's being affected with that. Alright. Okay. Remember, hold the Alt key for a moment. Left click and drag your mouse to the left and now down a bit here. Okay, here we go. Now, let's take game object, encapsulate this demon creature that you have.
So what I do, drag game object on top of ritual?
No. So let's just make it so that's encapsulating the demon altogether first, because it's a little off. It doesn't really match and bound the demon well right now. Hold the Alt key, click and drag to the right.
That way?
Sorry, I don't release the Alt key quite yet. Hold the Alt key and then click and drag to the right. Right, and let's pan a little bit to the left so you get a good view of this object from the front. Holding down the middle mouse button.
Yes.
There we go. Okay, and let's look a bit to the right. Let's make sure we have a decent view of it. There we go.
Is that over him now? I mean, it just has to be in the box?
I think you had it perfectly earlier here, so just Control-Z twice. Just twice. There, perfect. So it looks like it is centered. Let's decrease the size of this game object because that box is too large.
Like half of it or what?
Try 1, 1, 1, and then we'll go from there. Alright, and let's just move that box up so that it's not going through the floor. A bit more. There we go. And yeah, let's make it actually surround the game object there. There you go. That's a bit better. Now you can go from here and resize it all you want, but now let's make the layer 1 and 2 a child of this game object. Perfect. So now when you hit play, it should stabilize and not go through the floor. Or at least completely.
That's better. That's good. He sank a little bit, but it's muddy.
Yeah, so now it's just a matter of shaping the box collider around that daemon a little better.
Awesome.
So going forward, doing that, make it so that the layer 1 and layer 2 are not children of the box collider, of the game object that you have. And then resize and reshape the game object until you feel it's encapsulating the daemon like the way you want it to, and then make them children again.
Okay, I can get rid of this then. Ritual.
Yes, that's right, you can. And go ahead and rename game object too. That just makes sense if you do. Sounds good. All right, perfect. I'll let you edit, fine-tune that as you may.
Yep. Okay.
Yeah.
Let you go back?
Yes, I'm back. You can't stop me, Chad. I get to keep sharing.
All right.
Okay. So I'm going to start a new scene real quick, and we're going to show a little bit of the train making process. So, you remember in our scene we had the ability to create a train, and the way we did that was simply going into our hierarchy tab, right-clicking 3D object, and selecting terrain. There is our train. Now, a few steps that I found were helpful to getting set up were to elevate the terrain using the terrain tools, and then adding a layer underneath that was my water level. Simply moving the terrain up and down using the transform would not work. Wouldn't accomplish the same goals, because if we use our raise and lower height tools, you can see I can raise my height just fine, but I cannot lower them past a certain level, because by default the terrain is at the bottom. It's already as low as it can go. Now, before we do anything else, let's go to the gear icon. So I have my terrain selected. The gear icon on the far right of the terrain tool, you'll see it lists off a lot of its properties and components, everything about the terrain. If you want, you can always adjust the terrain width and height to make it bigger or smaller before you begin, and the terrain height, the terrain width and length to make it bigger, terrain height to allow it to be taller than it is. So right now it's at 600, so that means this terrain you can stretch up and make it up to 600 meters tall. If you want to make it any taller, edit the height limit. So Chad, if you're trying to make canyons, fiddle around with the height. Now, before we begin and get too invested in the terrain, let's make sure that we can at least lower the terrain, instead of only being able to raise it up. So to do that, we go over to our paint height tool. It's the second tool available in the terrain toolbar, and then we just go down to the settings where we can see the word height. It says 45 right now. Might say something different for you. You can enter a value that we're comfortable with. So let's say I put 30, and then I push that flatten button right next to it, and that will raise the terrain up 30 meters. And so now when I go to edit it, I can start to lower it and raise it. Lower and raise terrain. Awesome. Now with that said, let's take a look at some of the tools that are coming, or how to set it up. Now, you want to import the environments tab, so to do that, right click in your projects tab and go over to import package. From there you'll see the environment package. Click on environment. It will then prepare the package for you. If you want to import anything you've made, you would either click and drag them into your projects tab, or right click and import a custom package instead. So once Unity package is prepared for you, you can select exactly what it is you want to import. In this case, I already have everything I want, so I'm just going to select none just to demo here. And once you've got everything you want selected, just click on import. Boom, imports the package. If you want to import a custom package, a quick side note here is right click, import package, custom package, and then navigate to wherever it is that you want to import the package from. So in my case, if I go to my downloads folder, I have some VR toolkits that I could import. Anyways, with that said, we want to set up the water level for this terrain. So to do that, we go into our standard assets folder, environment, water, water 4, and then prefab. So the directory again was from your assets folder, you go to standard assets, environment, water, water 4, prefabs. And in there you'll find 2 prefabs. You want to select the one on the left that says water 4 advanced. This is the one that gives you this nice looking water asset. So I'm just going to bring that into my scene. I'm not going to just drop it anywhere. But you'll see it's much smaller than my terrain and it's off center. And that is because if you select your terrain, you'll notice that its movement center is the bottom left of its model. So you'll see that when I'm trying to move it, the bottom left represents its point of origin, whereas if I select the water, the point of origin is its actual center. So it's a little bit odd how that they're different, but that means we have to compensate for understanding exactly what it is. So let's take our water and just to show, we'll bring it up a bit so that we can see above the terrain. So right now I've positioned it up. What I'll do is I'm going to take the water for advanced. I'm going to position it in the center of the terrain. If you remember, this terrain is 500 by 500. If you remember when we were editing the settings and we went into the gear icon, we saw that the width and length were 500. If you don't edit those values, that means that the center is going to be 250. Then what that means is the X should be 250 and the Z should be 250, not the Y. The Y is going to be its height, and that's going to help us determine the water level. So now it's dead center. We know that the terrain is 500 by 500, and the water is actually only 100 by 100. So we need to multiply the X scale by 5 and the Z scale by 5. So now it's perfectly aligned with our terrain. Now we can choose our water level, and let's lower it down. So let's click W. We know that our terrain height, we flattened it to 30. Let's bring this water down to be underneath. You can even say, let's say 25. So it's just underneath the terrain. So now when we go over to our terrain, we can edit. Feel free to just manipulate that however you want. It's terrain selected. We can now go over the terrain tools. First tool, raise and lower height. Gotta raise the height. Looks all nice. There we go. And then we can also dig into the. Now we can do shift, left click and drag, create ourselves some nice looking rivers. And beyond that, you can also use different brushes, different brush sizes and opacity. So let's say I take this flat brush and then do this weird looking dome thingy. Anyways, with that said, you can also adjust the size and strength of your brush. I make my brush really small. I can start making small little rivets here, and if I decrease the opacity, that's going to be how strong my brush is. Now I have to really put in work to make it that high. Next is the paint height tool. This is what we used to at the beginning to flatten our terrain. If I was to do that again, boom, it would be flattened and I get a nice clean restart. But Control Z, I want to undo that and use the terrain paint height tool. So let's say I want to paint the height to be 35 or even 40. I can then use this tool. Let's increase the brush size a bit, brush opacity a bit, and let's start painting a height. Well, that's nothing. Let's increase this up to 75. Now you can start creating some plateaus, creating a bit of a canyon. So that allows you to build plateaus. Paint height tool is nice. You can also use it to sort of round off your mountains. If I bring this down, plateau going into your mountains. Perhaps a little harder to see just because it's so bright. But now with these, the next tool is the smooth height tool. This allows you to, as it was, basically it averages out the heights of the terrain around the area you have highlighted. So if the terrain's area is already the same, if the height is completely the same, it's not going to make a difference. Just like, let me decrease the size of the brush. If I'm looking at the plateau and I start using this brush, it's not going to do anything because all of the encapsulated terrain is already the same height. But if I put it right there on the edge and I start averaging out the height, it's going to really start to show a difference. It's going to round off the edges. Now I can do that all along the edges of this plateau, and you can see a noticeable difference here. Alright, and next is the paint texture tool, which is going to be the grass and sand and all that stuff you can paint. When you have that tool selected, you go to Edit Textures, that little option there to add a texture. When you decide to add a texture, a little prompt will appear called Add Terrain Texture, under which will be this little albedo RGB symbol, and in that square you'll see a Texture 2D slot. I'm going to click on Select, and you can now use any texture you want to start a paint over this terrain. Let's say I go with grass. You double click on it, and then you can click Add on the previous prompt. The first terrain you select will be painted all across your terrain. The first texture you pick will be painted all across your terrain. To change that at all, you need to go to Edit Texture again, add a texture, select another one. Let's say I select sand this time. And I can start painting with that one. So let's click Add. And then in this textures toolbar here, you're going to make sure you select the terrain you want to use, the texture you want to use. Then you can start painting sand over everything. Now, key difference to understanding opacity versus target strength. Let me make my brush size really large. I want to make it a solid brush. So if I set my target strength to 1, and I just click and drag a little bit, it will completely replace the grass texture. Let me make my brush actually a bit smaller. As you can see, it completely replaces the grass texture. If I set the target strength to, let's say, 31, it will only paint over about a third of the texture. If you set that to, let's say, 66, it's going to favor the sand more than the grass. That's it. Sort of like a gradual scale between the mixing of the two terrains. Opacity is just going to be how quickly that change occurs. So now I can just click once. I don't have to click and drag to make that change appear. And as you know, brush size is just the size of the brush. Next is the Paint Trees tool. With this, you can pick a tree, paint it onto your terrain. So if I click on Edit Trees, I can add a tree, and a prompt appears with the word Tree Prefab. So prefabs, as you know, we can bring into our scene. We can create some ourselves. The little circle to the right of that little slot that says None is where you can click to add something. So if I click and I add the typical tree that they give, this one, I add it, I can then start placing these guys down. Boom, just like that. Now, as I was saying with the ability to make custom prefabs, you can add a texture, you can add a tree, and then find a different prefab. Let's say we start using our hand as a prefab. So instead of painting those basic trees, I'm now starting to paint hands as trees. Cool. You know, nothing's stopping you. An army of hands. They're just trees. Alright, anyways. If you're far enough away, they tend not to render as well. Now with that said, part that we sort of glossed over last time was detail. Details allows you to paint billboards onto the terrain. These basically are small little 2D images that wave in the wind and always stare at the camera. So wherever you're looking at them from, they will come and face you. So represent that. I'm just going to take this brush and edit details. Just like the other two we've looked at, we have edit details, added grass texture. And it will then show you add grass texture prompt. The second one where it says detail texture, next to it is a circle. Select that circle and then you'll be able to pick a grass texture. Say I select that one, add, and I can start painting grass. And maybe, I don't know if you can notice this as well, but when I turn my camera, the grass turns to face me. That's the billboard effect. Yeah, now it's definitely more obvious that they're turning to face me. Yeah. And when I hit play, you'll see them wave in the wind. So these are things like wind factor you can use to affect these. But a lot of things you can do with the terrain. Now, as a heads up, these tend to be very resource demanding based on how many you have. It's not a good idea to have too thick of a terrain that's filled with these little billboards. So, it's your call if you want to use a basic grass texture versus these detailed things that do make it look much better, but there's a cost to everything. Alright, moving on. Let's take a look at some coding here. A little bit of coding review. So here is our player. We have 3 scripts: movement, shoot, and player controller. Let's open up our movement script. Now, when you create a new script, you typically just see something like this. We have a start function and an update function inside of a test class. At the beginning of the script, you'll see a few using statements. Typically, we've been leaving these alone, but these allow us access to libraries that allow us to do more things than just the basic C# functionality. The big one being Unity Engine. Now, this is what associates the C# program so much with Unity itself. Now, if you, for example, wanted to use a canvas, a text element, let's see if we can pull one up. This giant canvas that we created, it has a button, it has some text on that button. To be able to access that stuff, we need a little bit of code at the beginning that says using Unity Engine .ui. This allows us to edit things like text elements and buttons and all that UI element, all the UI elements. Things like allowing us to change the what the text says. For when we did something like shots fired, we were counting how many shots were fired. This is required to be able to edit the text UI element. Apart from that, this This function here, this line, includes the name of the script. In this case, it's test. If I go to where the script is located in my projects tab, I will see that the file itself is named test.cs. We have to make sure that name test matches that in this class. I've come across a lot of times where an error is simply caused by the fact that these two are not named the same. If you do not edit these when you create your scripts, you shouldn't have a problem. But if you said, oh, you know what, I don't like the name, I'm going to change it. If you change it here, you got to make sure you change the file name as well. Next, the two basic functions that come with it is the start function and the update function. The start function happens once at the beginning of this script. If you bring in an object that has a script attached, the first thing it will do is the start function. And then the update function runs every frame after that, over and over again. Now, let's take a look back at our if you see the curly bracket, let me get rid of this stuff inside. This curly bracket, when you select it, lights up another. That other one is the end of the scope. Basically, if you start writing things outside of that, try to write if something, it's going to give you an error simply because of the fact that it's outside the scope of the actual script. Chad, I'm getting a bit of echo from your end. Do you mind muting your mic?
Sure.
Thank you. So, as I was saying, those curly brackets define the scope of this big function. These other two define their own scopes. If you see as well, each function has a starting and closing curly bracket. If you want to do anything in the start function, you write it within these two curly brackets. Same thing with the update function. It has its own scope. If you want to do anything, you write it within the update function scope. Now, we haven't really used or we did, but at the beginning we weren't really using these parentheses for anything. But these are reserved for input. If you want to pass a value into a function, so that function has some unique value that other functions don't, you can put it in there. But you got to make sure that this function itself has a space for it. Kind of like our on-trigger-enter functions, we pass them a collider. We don't do it ourselves manually, but when the physics engine determines that something's entered the trigger zone, it then tells our on-trigger-enter function that this has happened. Void simply means that this does not have a return type. That means if you were to call this function, you can't go something like x equals start, because start is void. So let me create a couple functions here. So let's say we did void alpha. And we did something like int x equals. And then we had something like int beta. We did something like int x equals 3, return x. So now we decide in our start function we're going to go y, integer y. We declare an integer equals 0. And then later in our function we did something like y equals alpha. And we did y equals beta. Now, alpha is void, so it doesn't return a value, so this will just be null. Y equals nothing. Beta is an integer function. When a function has a variable type, that means it can return a variable. A void function, I can't do something like return x. This would be an error for the function because it's void. Alright, so this is just little extra thing. We'll get into it next week, or in the next session, I should say. But yeah, this is just something to keep in mind. When you create a function that's not void, you can then return something from it. That's the big main part of that. So anyways, let's go back to our movement script and take a look at what we've done here. So one of the things that we're doing at the beginning of our movement script, remembering that fact that the movement script has the same name in the class as well as the file, we declare two global variables. When I say global, what I mean is that the rest of the script has access to it. Every other function can see what these variables are. So that's why in the update function I can say multiplied by speed, multiplied by r speed. So any function can go, speed equals 2 or something, and then r speed equals 5, something like that. And I can do that same in the update function. I can go in the update function, I can say speed equals 2, no problem. I can say r speed equals 5, no problem. Now, if I decide to go like, if I declare an integer and I say this is x equals 2, so let's just say I declare an integer x, and then I go x equals 2, no problem. And if I do update, I do int y, I do integer y, I declare an integer, and say y equals 2, let's just say 3, no problem. There's nothing wrong with that. I declared a variable and I adjusted it within the start function. Great. Same thing in the update function, no problem. But now, if I try to go x equals 2, well, x equals 2, you'll notice that it says x does not exist in the current context. X was declared within the scope of the start function, which means it's born and dies within that function's scope. And then this function, this y, same thing. With this update function, this is the scope of the update function. So integer y is declared within the scope. It's assigned within scope, and then when the function ends, so does the y variable. The update function happens to be running every frame, so then it does that, assigns the value, it dies, and then update runs again, it's reborn, it's assigned a value, when the function ends, it dies. Okay, I have a lot more in here than I thought. Okay, I think that's good now. Now with our update function, we're using a lot of if statements. Now the general structure of the if statement is if with parentheses and then curly brackets. What this means is the if is checking to see if a condition is true. If this condition is true, then it's going to execute a command. So if some condition and then some command. You notice I put the semicolon at the end. That is something you do at the end of every command. See, every command, and then every condition is encapsulated in parentheses. The same can be said for the input of a function. So in the condition, what do we check? Let's take a look. We have our if statement. That's checking to see what? It's checking to see that if we're pressing the up key. So the up key is referring to the arrow key. It's doing input.getKey up. Input refers to the Unity's input manager, which contains all the keyboard inputs like your mouse as well as WASD, 1, 2, 3, backspace, all that stuff. It contains all of that. This conditions can be whatever you want, something like x is greater than 3. If the condition x is greater than 3 works, then you can do something, and some command can be executed. We just happen to say that this is an easy input check. So if that statement is true, that means this command that follows will be executed. The command this time is quick reference to the object this script is attached to. We attach the script to our player, so that when we go this.transform, we are referring to the player. This.transform, and transform has a lot of functionality to it. So if I went transform dot, I would see a list of things that it can do, rather large list. And if you like, you can click on one, hold down the left mouse button, click and hold, I should say, and you'll be able to see a summary of what it does. So I click and hold, I let go, I'll see that it tells me child count, the number of children the transform has. Compare tag. It's this game object tagged with tag. Click on something, and you'll see a quick summary. And in our case, what we did was translate. Now, you can do translate, you can do scale, you can do rotate, you can adjust a lot of its properties. And you can also get a lot of information from it, like the direction it's facing, what's in front of it, what's it looking at. And you can even do things like lerp, which we'll get into towards a couple of weeks from now. Alright, let's take a look at our shoot script. And where's our shoot? Shoot script is here. Awesome. Now, with our shoot script, we have variables of different variable types. One, we have public integer shots fired. You have transform and float and game object. As you know, integers are just whole numbers. Transform refers to the transform of an object. Float is just another number with decimal places. Game object refers to an object as a whole, with all of its properties, all of its components and properties under it. You can navigate through these things like a transform, like a game object, like a collider. You can do that simply by going, you can go game object dot transform, or you can go the reverse, transform dot game object. You can go back and forth like that, and you go dot get component or dot collider. I guess you need to do dot get component collider. Used to be that you can just do dot collider, but your own. Now, what we used spot transform for was to pick a spot to shoot from. So let's say if I find my gun here. Alright, this gun. It's a parent of two game objects. One being the barrel, because we wanted something to visually represent the barrel of the gun, but still be part of the handle. and the shoot location, which is an empty game object we use to determine where the gun will shoot from. And shoot force is going to be a value we edit to determine how much force is added to the paintball when it is spawned in. And then we have two game objects here: prefab paintball and spawned paintball. Now we have differences here because prefab paintball is going to be the object in our file folder. Spawned paintball is going to be the object in the scene. Let's take a look here. Go to my prefabs folder, and we'll see that this is the file. If I open up my file explorer, I can show an explorer, go to my prefabs folder. I can see my prefab in my folder. Do you want a quick reference? The projects tab here, it's just a quick access bar to your file folder. So I can go, I can click and drag my prefab paintball into my scene because this is the file. These are just pasted versions of it. These are just instances of it. But I can also do that from my prefab folder. Just go like that. Boom. Bring it in. Or I can't bring it in back into the projects tab because it's already there. It'd be as if you're clicking and dragging the same object into the same file folder. Anyway, so this prefab paintball is going to refer to this object in your projects tab. Spawn paintball is going to refer to one of these. These pasted versions, these spawned versions. So when we, in this case, we push down the mouse 0 button, the mouse 0 key, get key down, mouse 0, which is your left mouse button. And if I did not mention it earlier, this is also the same as a touch on your touch screen. So if you have a tablet, a mobile device, and you want to count a phone tap, this is the input for it. There's other options too, but just know that this counts. Now in our if statement we have the execution, which is spawn paintball equals instantiate. So instantiate works on its own, it does not need to equal anything, but instantiate prefab paintball spot transform.position spot transform.rotation. Prefab paintball, what it is we're spawning in, what it is we are instantiating. Spot transform, position, spot transform.rotation. So where we're spawning it and what the rotation of our paintball will be. Now we make it equal to spawn paintball so that we have a reference to it. So whenever we bring in a paintball, we quickly have a reference to it. And then we can, when it's in our scene, we can then, using that reference, find its rigid body and add a force in the forward direction. We'll multiply that force by shoot force. Add force needs a direction, which we can then multiply by some order of magnitude. And so then after we spawn it into our scene, we then shoot it and delete it, because then we can then bring in another one. Bring it in, shoot it, delete it. We're not deleting it from the script. We delete it from the actual shoot script itself. Now one thing we're just doing here at the bottom is shots fired ++, which is just helping us track how many shots have been fired. In our paint script, we started using our onTriggerEnter function. So the onTriggerEnter function looks like that. onTriggerEnter. It, unlike the start function and many others, it does in fact have an input method. It first looks for the variable type. So what this function is going to say is, I have an input, but that input needs to be a collider. And once you give me that collider, I'm going to temporarily name it other. And so what do? We check to see what the other is tagged as. You don't actually need to do game object, you can actually just do other.tag as an option. Fortunately at the time I thought this was necessary, but it's not. So if the other object is tagged as paintable, do this. If the other object is tagged as destroyable, do this. Now, entering the trigger, it's basically, we have our sphere here, our paintball. We'll see that the sphere paintball has a sphere collider and a sphere collider that is a trigger. So when it intersects an object, boom, like that, the computer tells the script that the physics engine for Unity tells the script that, hey, something has entered your trigger zone. So something has entered your trigger zone. I'm going to then tell you what that object is. I'm going to use that object and I'm going to give you its box collider. So this collider part, which says collider other, that is a reference to this other object's box collider. You don't need a specific name. It just lets you know that that is what it is. And then what we can do then is then find this other, which is the box collider, dot game object, dot tag. So then we see the tag, we find it, we check to see what is the tag. Is the tag equal to paintable? If it is, boom, we then paint it. So if I was to hit play here, when I bring this sphere into the scene, I should be able to touch the other object with it and make it pink, just like that. Because it knows it's paintable. And what it's doing is it's finding the renderer component of the other object and changing the material to a material that we have. And it will, if the other object is tagged as destroyable, it will destroy the other object after half a second. The start function, which runs at the beginning, is just going to start a little destroy function and just have it go off in 3 seconds. So destroy, pick whatever object it wants to destroy. So in this case, we're just destroying the script, or sorry, destroying the object this script is attached to. And comma 3 means after 3 seconds. Now let's take a look at our display script. One of the key things that we've sort of glossed over a little bit is the whole public-private function system. Let me open up our hand here. There we go. We've generally been keeping our functions, our variables, public. When they are public, that means they are visible to us in the inspector. Select my hand here. You'll see that since these variables are public, colliding object in hand. Just give me a second here. This is just loading. Yep, since these variables are public, I can see them in the inspector. Now, when it comes to the way we set up our grab script or hand script, we don't need to be able to see colliding an object hand. Those are handled by the scripts themselves. The scripts determine what colliding object is. The scripts determine what object in hand is. We are not supposed to assign a value there. So, for us to see it here, it's dangerous. We could accidentally be putting a value in here and there. So to avoid that, we can make these variables private. And it also makes our inspectors look a little cleaner, right? It makes it a bit neater. We don't have to keep track of so many variables. So we can make that private. So this is a little bit of addition thing we went over. Now, another reason for it to be public. So private, nice, you can hide the ones that we don't want to see, but it also prevents us from accessing them from other scripts. So let's say we have a display script. Our display script, if you remember, every time we shoot, we want that shots fired variable to update and show us in the text element. The way we do that here is the way we access other scripts. That's the important thing that we went over at the last week before we started the week 3, I believe. In the global variable slots here, where we are declaring global variables, we declared a shoot script variable. we called the variable shoot script, but the variable type was shoot because we have a script called shoot. So in our display AM script, we can simply say shoot. And because it's public, we're going to just click and drag that script so that it has a reference. Now, when we do shoot script, so I can go shoot script dot, and then I have access to all of its functions and variables. So shoot script happens to have a variable called prefab paintball, name, shots fired, shoot force, spawn paintball, spot transform. It has all these variables inside of it. So that calling that function allows me to see all of them. Now, in my shoot script, I also have this public integer shots fired. And I can see it in the other script. However, if I make this shots fired variable private, so if I go from public to private, save this now, go back to my display script, see now it turns red because it can't access this anymore. For me to access a variable from another script, that variable has to be public. Back to shoot, and we'll return this to public. Okay, so that covers the main concepts so we've gone over. There's more stuff, but I hope that gives you a bit of a refresher on what we've done so far before we got into VR. So I'm going to save that again, and well, that's today's class. We did a solid review. We have Wednesday off. We'll resume regular classes the following week. All right. Do either of you have any questions?
No, sir. That was very helpful. Thank you.
Awesome. I'm glad to hear it.
Yeah, thanks. Can I show you something real quick?
Of course. Yeah, let's take a look.
So, oops, finally got this working, sort of. I still got to do some stuff, but
unable to see your screen right now, Chad.
Oh, you can't see?
No, I don't want you to spend too much time explaining something and then I'm not able to see.
Okay. All right, here we go. Can you see?
Yeah, I can see now.
Now, all right.
It's a scary looking creature you have there, man.
Ow! I gotta redo my room. But, so I got my guy there, and instead of my cube, that's my guy. So. Anyway, that's as good as I get.
That's awesome. All right, right on. Did you have any questions for that, or that's just show and tell?
I mean, just the gravity was I was not able to use them as a target because he kept falling through. But yeah.
Awesome. That looks good. Share that on Slack, okay? I want other people to see that.
Cool.
That's dope.
Thanks a lot.
All right, I'm gonna stop the recording, guys. You guys have a good weekend. If any of you guys are near LA and you want to stop by VR LA, that'd be awesome.
Enjoy yourself, man. Have fun.
Thank you, guys. Take care.